In this video, we are going to talk about VLAN trunking protocol, or VTP. We are going to cover VTP versions, VTP messages, and VTP configuration. VTP comes in three versions. Versions 1 and 2 are something that I like to call the traditional VTP. The traditional VTP is supported by almost every single Cisco switch in every single iOS version. These two versions are almost identical. The only difference is that version 2 adds some additional support for token ring VLANs, and really this is not very relevant in this day and age. VTP versions 1 and 2 operate in three modes of operation: client, server, and the transparent switch. I'm going to talk about modes of operation in just a minute. VTP version 3, on the other hand, is much more complex. With VTP version 3, we have support for multiple databases. So it's not only the VLAN information that can be propagated, we can propagate some other things as well. Again, this is something that I'm going to talk in more detail in one of the subsequent, more advanced videos. Also, what VTP version 3 does is it supports a multi-level client-server architecture. That means that not only do we have servers and clients, we have primary servers, secondary servers, we can have clients, and also we can have transparent VTP switches. Unlike versions 1 and 2, on the switches that support VTP version 3, we can actually turn off VTP completely. But all this is fine. What is VTP actually used for? Let's take a look at that. When we have a network consisting of a single switch, it's very easy to create VLANs. So we have a single switch. If we want to create a VLAN, we simply go to this switch, we create the VLAN, and we have segmented our switch into two virtual broadcast domains. When we have more than one switch, like for example, if we had two switches, if we wanted to create two VLANs, let's call them 10 and 20, on these two switches, we would have to actually configure both switches. We would have to configure our switch 1, but we would also have to configure our switch 2. So let's call this one switch 1, and let's call this one switch 2 here. So this creates additional workload. What if we had a network that consists of more than just two switches? If we had 4 or 5 or 6 or really any number of switches. Whenever we wanted to create a VLAN here, we would have to go to every single switch in our network and create those VLANs there. This creates a management problem. Problem that can be resolved using management tools and the orchestration tools and the provisioning tools that exist or may not exist out there in the world. And this is something that Cisco realized very, very early on in its history, and this is why VTP was created. VTP was the solution for this problem. Well, this solution also creates some problems of its own, and this is why using VTP is a decision that needs to be carefully weighted in a case of deployment. Generally speaking, the way VTP works is when we create a VLAN on one switch. Let's say that we create a VLAN here on our switch number 1. Switch number 1 is going to propagate this information that the VLAN has been created to its neighboring switches. These switches are then locally going to create their own VLANs and then propagate this same information to their own neighbors, just like this. So what ends up happening is that the VLAN number 10 gets created in our entire network. The way this information is propagated is using VTP messages. So let's explore what VTP messages are there. There are 4 types of VTP messages. These are summary advertisement, subset advertisement, advertisement request, and VTP join message. Summary advertisements are sent periodically by clients and servers in the domain. These messages are also sent in response to received advertisement requests. These messages are also sent whenever there is a configuration change in our VTP database. The configuration change is VLAN being created, VLAN being deleted, VTP domain being changed, or anything that affects the contents of our VLAN database or VTP database. Subset advertisements are sent when the VLAN gets created or changed, when there is a change in the database. And also these messages are sent in response to the advertisement request message. Advertisement requests, on the other hand, are sent when the switch is being reset, when there is a domain change. Let's say that I had a domain called A and I change it to domain B. In that case, the switch will send the advertisement request to see if there is a server or a client out there in the network that may have a revision number higher than the locally configured one. Also, these messages, advertisement requests, are going to be sent when we receive a summary advertisement with a higher revision number than the one that we have in our own database. Lastly, VTP join message is used for VTP pruning operations, which I will explain a little bit later. I have mentioned VTP modes of operation several times, like server, client, and transparent mode of operation. Let me talk about them for a moment. Server mode of operation is the default on Cisco switches. That means when you have no configuration on the switch, when you just boot it up, when you received it from Cisco, it will be operating in a server mode. In server mode, you are able to make local changes to the VTP database. In other words, you can create and delete and modify the VLANs on the switch itself. When this modification happens, the switch is going to use the VTP messages to inform other switches about this change. Servers also allow for network-based configuration change, which means that when they actually receive a message that has a higher revision number, they are going to update their database according to the contents of the received message. The client mode of operation does not allow any local changes. In other words, when you create the switch, when you move the switch to be in a client mode of operation for VTP, and you attempt to create a VLAN locally on the switch, you're going to be met with the error message telling you that you cannot modify the database in the client mode. Clients can only be updated from servers. Well, I should maybe correct myself there. They can also be updated by other clients, and this is something that I'm going to show you in a moment. When a client receives a VTP message with a higher revision number than its local revision number is, it will update its local database. Now, remember that summary messages, summary advertisements, and the subset advertisements are also sent by the client. If it so happens that you have a client that has been powered off for extended period of time, and for whatever reason it had revision number, let's say 500, and on the other hand, you had switch that had lower revision number that you were updating and you changed and upgraded your network, and you're connecting this old switch to your network. If it has a high revision number, even though it's a client, it will actually send out the advertisement and update your active database. So be careful about that, because the clients can also update other clients and servers as well. Finally, transparent mode switches, they allow you to change the database locally on the switch. That means you can create, add, and remove and modify the VLANs locally on the switch, but these changes are not propagated to the neighbors. That means no VTP messages are going to be sent out as the result of your local VLAN database change. Also, when transparent switches receive a message from a VTP client or a VTP server, if that message happens to be in the same management domain, in the same VTP domain as the transparent switch is just going to relay the message. It is not going to change its own database in any way. That means network-based updates are not allowed, but this message will be relayed to other switches in a case they need to modify their own databases. One thing that I forgot to mention is that VTP does not work on access ports. It works only on trunks. So this is number one prerequisite for successful VTP deployment, is you need to have trunks. Are you going to be using ISL trunks or .1Q trunks? It doesn't matter. Just you need to have trunks. Several times so far, I have mentioned important VTP concepts like VTP domain and VTP revision without actually explaining them thoroughly. So let me spend a moment explaining that. VTP domain is a string that identifies the management domain, the set of switches that are going to be updated by the same set of servers in the network. It's just an alphanumeric string. By default, there is no domain on any Cisco switches, and this is a very, very special situation. When the switch doesn't have a domain, VTP domain set, the first update it receives from any other switch with the correct domain will be accepted, and the local switch will change its domain from null, from nothing, to the received domain's identifier, the domain's name. VTP revision number is just a number. Basically, it identifies the serial number of the configuration in question. There is no comparison of the database when we receive an update from another switch. That means that if our revision number was 5 and we received revision number 6, we are going to take the information from the subset advertisement, which is the list of all VLANs that exist on that switch that advertised this message, and we are going to replace our own local database with the contents of the VTP message that we received. There is not going to be a merging of VLANs, there is not going to be any advanced intelligence. We are simply going to overwrite our own database. Again, this is a potential problem area. And now it's the time to actually stop talking about VTP, and it's time for me to actually show you VTP in action. To do that, I'm going to use a very simple network consisting of two switches, Cat1 and Cat2. They are going to be directly connected on port FastInternet 24, so on both sides I'm going to use FastInternet 024. And also to Cat2, I'm going to have a Linux PC connected on port FastInternet 03. I'm going to use this PC to capture the packets. I want to capture the frames. I want to see all those VTP messages that I just talked about. So let's go ahead and configure this and see how VTP operates. So here I am on Cat1. I just want to see the current configuration of my relevant port. So this is FastInternet 24, the port that is facing my Cat2, and as you can see, it is shut down. On Cat2, this is the configuration, and as you can see, this port has been configured as the trunk. And also, if I do show run interface FastInternet 03, I can see that FastInternet 03 is shut down. So I'm going to go to FastInternet 03, I'm going to do no shutdown on this port, and before I configure the connection between my two switches, between Cat1 and Cat2, I want to make sure that my span session, that my monitoring has been configured and is in place. So what I'm going to do is I'm going to say monitor session 1 source interface FastInternet 24. I'm interested only in the frames that I'm receiving on this port, and I'm going to say monitor session 1 destination interface FastInternet 03. And because VTP works only on trunks, I need to make sure that the destination port preserves the original markings on the frames, similarly to what I've done for my presentation on ISL, if you remember that video. So I'm going to say encapsulation replicate here. So if I do show monitor session 1, I should be seeing that I'm monitoring the received frames on FastInternet 24, and also that the encapsulation is replicate. So now I have my monitoring in place, and let's go to my Wireshark and let's start the capture. So I'm going to start the capture on Cat2, and as you can see, I'm receiving no traffic. That's because the interface is shut down there. I'm not going to be interested in any frames other than the actual VTP frames, so I'm going to configure a filter in my Wireshark to capture only those frames. Going back to my terminal, let's confirm the configuration on FastInternet 24 on Cat2. It's a trunk, and I need to make sure that the same configuration exists on Cat1. So I'm going to go to interface FastInternet 24. I'm going to say switch port trunk encapsulation .1q switch port mode trunk. So now I have configured my interfaces to be ready for my VTP. The interfaces are still shut down. I want to do this in a controlled fashion because I want to show you couple of things. The first thing that I want to show you is a verification command for VTP, which is show VTP status. As you can see, in the output of this command, I can see that on my switch, I have the capability to run 3 versions of VTP. VTP version 1, VTP version 2, and VTP version 3. Currently, this switch is operating in VTP version 1, and we can see here the special situation that there is no VTP domain. I'm going to have the same situation on Cat2. I'm going to run show VTP status, and I can see that the output is pretty much the same. So I'm now going to go back to my Cat1, and as you can see that there are almost no differences between these two switches when it comes to the configuration. Pretty much the only difference that we can see here will be the MAC address. This is on Cat2, and this is on Cat1. Furthermore, these two switches are relatively close to each other in the date of manufacture, which you can see by the fact that only these numbers here are different, and they are also very, very close. So we can see that for VLAN mode, and this is the output that you're going to see on the switches that are capable of running VTP version 3. This, when it comes to VTP version 1 and VTP version 2, feature VLAN, the VLAN database, is the only thing that is communicated in VTP. But remember that with VTP version 3, we have capability to communicate some other things other than just the VLAN database. So this is why in the display of show VTP status, we are going to see the VLAN database separately, even though it will be the only feature that we are going to look at right now. So what I can see here, and let me bring this up a little bit. I can see that VTP is operating in the server mode. We can see what is the maximum number of VLANs supported locally, what is the actual current number of existing VLANs, and this is the default, because there are 5 VLANs in the database that we cannot delete. These are the default VLANs for Ethernet, the token ring, FTDI, and so on. And finally, we can see here MD5 digest of the whole database. I should point out that this MD5 digest, contrary to what you might read, is not only the password. VTP does support authentication, but this is the MD5 digest of the whole database, including the password, which at this moment is not set. If I do show VTP password, I'm going to see that VTP password is not configured. If VTP password was configured, this command here would be able to show me what the VTP password is. So this is the default configuration. This is what happens with the switch when it initially boots up, when it has no VTP configuration in place. Let's bring the interface up between the two switches now. So I'm going to go to interface fastnet 24, and I'm going to say no shutdown. When the interface comes up, which should happen just about now, there we go. When the interface comes up, the VTP messages should start flowing. So let's go and take a look at our Wireshark. Am I receiving any VTP messages on my Cat2? As it turns out, I'm not receiving any. The reason for that is the special situation we have here. So let me go to Cat1 here, and I'm going to say show VTP status. Again, when we have a null domain, and in this case we have null domain on both sides, there are not going to be any VTP messages. Why? Because null domain is a special case, as I mentioned so many times so far. When we have null domain, we are waiting to hear for the first valid VTP message so that we can actually learn the domain in which we are going to operate. Alternative to this is actually setting the domain manually. So if I go and take a look at my Wireshark, still no messages flowing. Just for fun, on Cat1, I'm now going to create VLAN number 10. So if I do show VLAN brief here on Cat1, I see now that VLAN 10 has been created. Still, no messages in VTP. If I go to Cat2, if I do show VLAN, I will see that VLAN 10 has not been learned by Cat2. Let's go to Cat1 and change the VTP domain to something else. Let's call this Cisco. So now I have changed the VTP domain to Cisco. If I go to my Wireshark, take a look at this. Now I actually do have a VTP message in. Remember, these are the messages that we are seeing going from Cat1 to Cat2. So let's see what these messages are. So this is the first message that we received here, and we can see that this was actually a summary advertisement message. What we can see in this message, the important bits, are the followers line. The followers field tell us how many subset advertisements are going to follow this summary advertisement. Remember, in the subset advertisements, we are going to have the information about the VLANs configured on this switch. Also, what is important here is what is the management domain, and also what is the revision number. These are the important bits. Also, of course, the MD5 digest, which is, remember, the digest over the whole database, not just the password. But the more interesting thing is, what happened on Cat2 as the result of this message? If I do show VTP status now on Cat2, you see here that we have now information about the domain name. Cat2 now learned the domain. Okay, this is good. Also, if you repeat our show VLAN brief, remember that previously we didn't have VLAN 10 on Cat2. Now we actually do have VLAN 10. How did Cat2 learn this? Well, going back to our Wireshark, and here is our subset advertisement message. Let me collapse this output here just a little bit. So in this subset advertisement here, we are learning that this is of course happening in the management domain Cisco and the configuration revision 1. We are actually learning about some VLANs. Here is our VLAN 10. We can see here that this is the VLAN information field in our message. We can see that this is dealing with the Ethernet VLAN. VTP supports different media types, remember that. And also here we can see that this is ISL VLAN ID A. And remember that A, hexadecimal in decimal, is number 10. Why does it say ISL VLAN when we are actually using .1Q between our Cat1 and Cat2? Well, that's because VTP was originally designed to work with ISL. Therefore, it continues to think it's propagating ISL information. This has somewhat been remedied with VTP version 3, which can propagate VLANs higher than 1025, right? The extended VLAN range, which VTP versions 1 and 2 cannot propagate. So now we see that Cat2 actually learned this information. But Cat2 is also operating as a server. So we can see here that Cat2 is the server. If I go to Cat1 and I change the domain from Cisco to something else, let's see what happened in my Wireshark. The first thing here that I'm getting is the summary advertisement. Now, my Cat1 sent a summary advertisement saying that, okay, I'm now in a different domain. I can see here that it says management domain IPX. This is to be expected because we have changed the management domain. Also, what I'm going to see here is going to be a subset advertisement in the new domain. Let's go back and change the domain back to Cisco. But before I do that, I want to show you something. Now, if I do show VTP status on Cat1, I'm going to see that now we are dealing with the configuration revision 0. When I change the domains, I automatically reset the configuration revision to 0. Also, when I change the configuration mode, the operational mode, from client or server to transparent and back, I'm again going to reset the configuration revision to 0. So now what I'm going to do is I'm going to change the VTP domain to Cisco. Let's go back to Wireshark and see what happened now. I see that in the meantime I have received quite a few messages. Let's take a look at this one here. Now, this was the summary advertisement. This was sent by Cat1. Now, I am in management domain Cisco, but take a look at the configuration revision number. It's 0. This here is going to be a subset advertisement with the revision 0. This message here is actually advertisement request. Why do I get the advertisement request here? Well, here is why. Because when I change the domain, so domain changed from IPX to Cisco, what happened is that I sent the summary advertisement, I sent the subset, but also what happened here was that from cat2 I received a summary here. But this one had the revision 1, while these two here had revision 0. Now, this message here will have a higher revision number than the one that we had on cat1. This, in turn, triggers cat1 to send out the advertisement request. Basically, cat1 is now telling cat2, hey, you know what? You have a higher revision number, send me your database. So going back to our Wireshark here, we can see that as the result of our advertisement request, we are now, that we have actually sent out our summary and subset advertisements, and we can see here the confirmation of that. This is again going from cat1 to cat2. We now see that cat1 is sending us now the correct information with the revision 1. Basically, cat1 came back into, let's say, good grace of domain Cisco. We are not yet done with VTP. You remember when I said previously that one of the big problems with VTP is that the database contents are not compared when we receive the advertisement with the higher revision number. That whatever we receive is simply going to overwrite our local database. This is actually a very dangerous situation. This is something that in the industry, network engineers fondly call the VTP bomb. Let me show you the VTP bomb in action. So I'm going to go to our cat1 and cat2 now, and I'm going to shut the link down between them. So there we go, the link is now being shut down. Remember, they're both in the same domain called Cisco. So what I'm going to do now is, on cat1, I'm going to create a couple of VLANs. So what I'm doing now is I have created 1, 2, 3, 4, 5, 6 VLANs. So if I do show VTP status, what I should be seeing here now is that my configuration revision is 7. Furthermore, what I'm going to do now is I'm going to change the mode of operation on cat1 from server to client. So VTP mode, client. If I do show VTP status, I can see now that my VTP operating mode is client, and I can see that my configuration revision is 7. Going to cat2, remember the link is shut down between them, I'm going to say show VTP status, and I can see here that I have a configuration revision 1. Now, on my cat2, I'm going to create, let's say, 100 VLANs. So I'm going to say VLAN 100 to 199. Even though I have just created 100 VLANs, this still constitutes just a single revision bump, because I have created these 100 VLANs in a single database write. Remember the VLAN database, it's a file stored on the flash memory of the switch. So now I have a configuration revision 2 with 106 VLANs on cat2, and on cat1 I have a configuration revision 7 with 12 VLANs. Let's bring the link back up between them. So I'm bringing up the link between cat1 and cat2. The link is now up. Let's go to cat2 and repeat our show VTP status. We can see now that we have configuration revision 7 and only 12 VLANs. Just a second ago, what we had here was the situation that we had configuration revision 2 with 106 VLANs. That means that we have lost these 94-ish VLANs in less than 1 second, and there was not a single warning message that we received in iOS about it. Nothing. This is VTP bomb in action. When you decide to use VTP, either in the lab or you decide to use VTP in your production environments, this is something that you need to be very, very careful about, because this is the real danger about the VTP. Next, I would like to take a look at the VTP transparent mode. For that, I'm going to need one more switch. So I'm going to extend my network now from just Cat1 and Cat2 to Cat1, 2, and 3. So I'm going to have my switches connected like this. This is going to be port FastEthernet 024 on both switches, and this here is going to be port FastEthernet 020. Let's go to terminal and take a look at this. So I have Cat3 here, and if I take a look at port 20, I can see that it's actually shut down. On my Cat2, FastEthernet 20 is also shut down. And let's go and configure this port to be in .1q. So switch port mode trunk, and also on Cat3, interface FastEthernet 20, switch port trunk encapsulation .1q, switch port mode trunk. I'm going to do no shutdown on Cat3, but it's still shut down on Cat2. If I do show VTP status here, I'm going to see that I don't have any VTP domain configured, and I also am going to see that I'm operating in a server mode. I'm going to change this to client. So VTP mode client, but I'm not going to make any other changes. On Cat2, I'm going to say no shutdown, and I'm going to go back to Cat3 and wait for my port to come up. I can see now that the port has changed state to up. And I'm going to see what my VTP status says now. I can see at this moment that I have configuration revision 7 and also that I have 12 existing VLANs. This is the exact same configuration that I had just a minute ago. Cat2 is now the server and Cat1 is the client. Let's confirm that. Let's make Cat1 a server. So I'm going to make Cat1 the server here, and I'm going to make Cat2 a transparent switch. Also, I'm going to enable a debug on Cat2. I'm going to say debug switch VLAN VTP events. I want to see all the VTP events as they are going on my Cat2. Now I'm going to go to Cat1 and I'm going to create a VLAN. When I create VLAN 80 here, I can see 4 log messages on Cat2. I can see that the packet received on port FastEthernet 24, that's the port facing Cat1, is now being relayed in transparent mode. I can see this happening twice for the packet received on FastEthernet 24 and twice for packets received on FastEthernet 20. Why am I seeing it twice each time? Remember, summary advertisement and a subset advertisement. If I go to Cat3 now, and if I repeat show VTP status, I can see that I have revision number 8 and I have 13 VLANs in place. That means that my Cat2, the transparent switch that was sitting between Cat1 and Cat3, has successfully relayed this message across. But what happens if Cat2 is not in VTP domain Cisco? And also, this relayed message, did it actually create a VLAN on Cat2? Let's take a look at both of these. So going back to Cat2, if I do show VTP status, I'm going to see that my configuration revision is 0. Remember earlier when I said that changing the operational mode from client or server to transparent or back from transparent is going to reset the revision to 0. We can see it right here. And also, I can see that I have only 12 VLANs. I don't have the 13th VLAN that I just created. What happens if I create a VLAN locally? So I'm going to say VLAN, let's say 101, 102, 3, 4, 5, 6, 7, 8, 9, 10. I wanted to bump up the revision numbers here. So if I do show VTP status, look at this. Configuration revision is still 0. Nothing has changed, but I do have 22 VLANs. Did this do anything on Cat 1? I'm missing a show here. There we go. 13 VLANs and revision 8. So absolutely no effect. But if I create another VLAN here, let's say, what was the last VLAN that we created? 80. Let's create VLAN 90. I can again see a relay message here, and on Cat 3, the VLAN gets created and the revision number is bumped up. So no effect on the transparent switch. That means that the packets are just going through. And also, when we create a VLAN locally on our transparent switch, that doesn't affect our clients or servers. But what happens if Cat 2, which is now a transparent switch in domain Cisco, is not in domain Cisco? Let's say VTP domain IPEx. So now when I change the domain, let's see what happens when I create the VLAN. I'm going to say VLAN 100 here. I'm going to create it, and let's go to Cat 2 and take a look at this. Now the packet received on FastITNet 24, remember that's the one that is connected to Cat 1, is not being relayed. We are dropping the packet here because it says it's not in domain Cisco. Actually, it says that we are not in domain Cisco. Cat 2 is not in domain Cisco. The received frame is in domain Cisco, and therefore it's not going to get relayed. We can confirm this in a moment. If I do show VTP status on Cat 1, I can see that I have 15 VLANs and that I am in configuration revision number 10. On my Cat 3, if I repeat show VTP status, the VLAN was not created because Cat 2 didn't relay the message. We're almost done. The next thing that I want to talk about is VTP authentication. VTP supports authentication of packets. Now, I'm not going to talk theoretically about this, I'm just going to show you this in action. So I'm going to go to my Cat 1 and Cat 2. And the thing that I'm going to do first is I'm going to make sure that all the debugs have been turned off on both of the switches. And I'm going to make sure that I have reset my VTP database to revision 0, or my VTP revision to 0. So I'm just going to say VTP mode transparent, and I'm going to delete all the VLANs that I won't be needing. Same thing here, VTP mode transparent, no VLAN 2, let's say to 2000. So I'm just going to delete all the VLANs that I have in the database that might be there. I'm also going to make sure that my VTP domain is Cisco, and also that I don't have any VTP passwords configured. Just like this. So if I take a look at my database with do show VTP status, I'm going to see that Cat 2 is the transparent switch and it's in the domain Cisco. I should be seeing the same thing on my Cat 1. I can see it's transparent and it's in domain Cisco. Also, I can see that VTP password is not configured. There is a reason why I went through all this trouble. On Cat 1, I'm now going to create VLAN 10. Remember, this is a switch in transparent mode. Also, I'm going to create on Cat2, I'm going to create VLAN 20. Again, remember this is a switch in transparent mode. If I do show VLAN brief on Cat2, I should be seeing VLAN 20, and on Cat1, I should be seeing VLAN number 10. So far, so good. I'm going to change Cat1 to server mode, and I'm going to change Cat2 into server mode. Now, both of these devices are in server mode. But take a look at the error message that I have received on Cat1. I'm fairly certain that soon I will receive it on Cat2 as well. Now, it says here that I am receiving MD5 digest checksum mismatch on receipt of equal revision summary on trunk fast Ethernet 24. This is a rather cryptic message. There is no password configured. So what is this summary all about? Well, let me show you show VTP status again. If I do show VTP status on Cat1, I can see that this is a switch that operates in VTP server mode in domain Cisco. I have 6 existing VLANs and the current revision is 0. If I go to Cat2 and I repeat the exact same command here, I will see that this is a switch in switch that has 6 VLANs, revision 0, and this is the domain Cisco. But take a look at these 2 lines here. This is the MD5 digest of the actual database. So now I'm on Cat1, now I'm on Cat2. Let me bring this up just a little bit. So this is Cat2, this is Cat1. You can see that they clearly don't match. Now, the reason for that is that this is the MD5 sum over the contents of the whole database, not the password. Now, we have the same revision number on both of our switches. The same number of VLANs, so there is really nothing for the switches to go on about to figure out which one of these 2 databases should win. This is a MD5 mismatch that we are talking about. The switches cannot synchronize their databases. The solution for this problem is a very simple one. Just create a VLAN on one of the switches, VLAN that you don't need, and then immediately delete it. This will bump the revision number, override the other database, and we are done. Now, the problem here is that if I say create VLAN 30 on Cat2, this will immediately delete VLAN number 10 on Cat1. So the best approach here on Cat2 would be to just create VLAN 10. Now, when I create VLAN 10 on Cat2, I'm going to bump up the revision number of Cat2, but that also means that this new information is now being sent to Cat1, and now Cat1 will have both VLANs 10 and 20 in its database. So if I do show VLAN brief, take a look. I have VLANs 10 and 20. Furthermore, if I do show VTP status, and I really need to learn to type this show command. Let's repeat the same thing here. Oops, I overdid it a little bit. Now, we can see, now I'm Cat1, Cat2. Take a look at the MD5 summary. It's identical. There are no differences, so I'm going to highlight the one on Cat2. So when I switch the tab to Cat1, you see, there are no differences. The databases have now been synchronized. Now, why am I talking about this particular problem or this particular behavior in a section where I'm supposed to talk about VTP authentication? Let's turn on VTP authentication. So on Cat2, I'm going to say VTP password Cisco. Let me show you what happened. So I'm going to do show VTP status. So nothing has changed on Cat2 other than I have changed the password. And take a look at the MD5 summary. I'm just going to highlight one of these numbers. This is on Cat 1, and this is on Cat 2. You see the difference? On Cat 1, it's 6E, and on Cat 2, it's 56. Now, our MD5 summaries no longer match. But the non-matching MD5 summaries can be the result of other things, not only the password mismatch. Now, of course, now when I add the VLAN on, let's say, Cat 2, let's say VLAN 30, this is going to be sent to Cat 1. But Cat 1 is now not going to have the VLAN 30 created because now the authentication doesn't match. So in order to make this work, I need to make sure that my passwords actually match on two sides. So if I do show VTP status, show VLAN brief, I still don't see VLAN 30. Why don't I see it now that passwords match? Well, remember, the summary advertisements will be sent every 5 minutes or when there is a database change. Has the database changed on Cat 2? No, it hasn't. So Cat 2 is not advertising the new database, but that's easily solved. I'm going to create VLAN 40, and then I'm going to remove VLAN 40. So now, if I do show VLAN brief, this has triggered a database change on Cat 2, and now I see my 3 VLANs, 10, 20, and 30. The last thing that I want to talk about in section about VTP is really an unusual one. So I'm going to spend just a couple more minutes on this. By default, you remember that I mentioned VLAN information on Cisco switches is held in a file on a flash called VLAN.dat. So if I take a look at my flash here, I'm going to see VLAN.dat file. But you don't have to keep VLANs there. You can actually change the file where the VLAN information is being held. To do that, you actually need to change where VTP stores its information because it's the same database that is being used. The command for that is VTP file, and then you give the address of the file. Let's call this myVLANs.database or .db. Now we can see that device is now going to be using a different location for VLAN information. If I take a look at this, now I can see that I have actually a file called myVLANs.db. I'm now going to delete the file called flashvlan.dat, and when I do this, I'm going to shut down all the ports on this switch to isolate it from all the others. So the reason why I'm doing this is I don't want to learn any VLAN information from my VTP neighbors. I want only local information to exist. There is a good reason why I'm doing this. So if I take a look at my flash memory here, I can see file myVLANs.db, but there is no trace of VLAN.dat. I'm going to save the configuration, and I'm going to reload my switch. Now, let's wait for reload to finish. Okay, that was quick. Now, that when the switch has rebooted, and remember, we have deleted the file called flashvlan.dat. Let's take a look what we have on flash now. That file is gone. But what happened with our VLANs? If I do show VLAN, I can see that all my VLANs are still there. The reason, of course, is that we are no longer using VLAN.dat file to store VLAN information. As I said, this was a little bit unusual thing, but it's good to know. And I think that this is it about VTP versions 1 and 2.